My tutorial is on trig identities. When you're given an equation or like a problem that says prove that cos squared x equals cos squared x minus sine squared x, you're essentially trying to prove that the first equation equals the second equation. And I guess technically you're not doing any real math, you're just simply rearranging equations using like the identity catalog and like previous math knowledge. And something that's really important is proper notation. And the way you do this is you set up like a t-chart kind of thing, I guess. And you have to write left side equals right side. And then you're going to write out like cos squared x equals cos squared x minus sine squared x. And then all of your like following things would have to have like equal signs next to them. And yeah, when you finally got your final answer, you have to do left side equals right side. Yeah. So just make sure you follow that whenever you're solving trig identities. There's just some general tips. I mean, there's no really, like, I guess, set order way to solve them. They're all kind of different. So the first thing you could start off with is changing all terms to sine and cosine. Then adding and subtracting fractions with a common denominator, because I find that that's kind of, like, frequent. You just want to, like, look for that. Really look at your green sheet and kind of see if you can see anything similar to what's on your paper. Know where you're heading and look at each side, kind of see like, oh, if you have a cosine on the bottom, then you need to like rearrange to somehow get a cosine on the bottom on the other side, and start with the most complicated side. I find that really helps. And if you fail, don't get discouraged, just try again. Really, like, there's no, I guess, like, set thing that will work for every trig identity. You just have to try, and then eventually you'll kind of memorize the patterns and things like that. Alright, so getting right into our first example, we are given this problem that says prove that blah 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 equals blah blah blah. Anyway, so right off the bat, I set up proper notation already, and I wrote down the first equation on the left side and the second equation on the right side. And I'm going to start with the most complicated side, which in this case is this side. Let's just check off as we go. So right off the bat, I see right, like, just sine 2 theta, and that initially should just click in your head as a double angle formula. So I'm going to look to my green sheet. So I'm going to use this one for the first term and this one for the second term, and I'm just changing the tops. Alright, so we're going to get 2 sine theta times cos theta over sine theta minus 2 cos squared theta minus 1 over cos theta. And just, again, I'm using my identities right there. Okay. So next I see two terms being subtracted from one another, and I know that I need a common denominator because they're fractions. So on this side I'm going to multiply cos theta. I wrote x, but I meant theta. And this side I'm going to multiply by sine theta. Which reminds me that theta and x are the exact same. They're just an unknown number, so don't get confused by them. You know, I know our sheets say x, but they're the same. If you see theta on a test, don't fret. Okay, so I now, once I multiply that in, I will have a common denominator, so let's go do that. So I will get 2 sine theta times cos squared theta. I trust you guys know how to FOIL at this point, or multiply in, I guess, or distribute is the word. 2 cos theta squared theta, I meant. Sine theta plus sine theta. And because we're merging it all into one fraction, it'll say, the bottom will say sine theta and cos theta. Alright? So just using your excellent math knowledge that I know you guys are all capable of, we can basically cancel out everything on the top and everything on the sine theta on the bottom. And because we've canceled out everything on the top, we're left with a 1. An imaginary 1 over cos theta. And hey, on this side, we know that because of our reciprocal functions identities, we know that secant theta is equal to 1 over cos theta. So just looking back at the steps, I got a common denominator. I tried to look ahead. I saw that there was a cosine on the bottom, and I thought, okay, we're definitely not working with secant. So, you know, I was thinking ahead that I might change this to 1 over cos theta. Then I just canceled out, and finally, we got to do our final notation. And we're done. This problem is solved. For a second example, we have like kind of an easier one, which doesn't actually require any grade 12 math. You could have done this in grade 11. But yeah, all trig identities are kind of similar. You just got to really practice and you know, you'll eventually get it. So I've already set up proper notation, all of that. My terms are both already in sine and cosine, so I'm just going to start off with the most complicated looking sign, which is this side. So right away, I kind of see that I have, looking ahead, I see that I have a 1 plus cos x on this side, and I have a 1 minus cos x, so I can get rid of the sine x, the sine squared x. So I'm going to look at my Pythagorean identity, and I'm going to change sine squared x into 1 minus cos squared x over 1 minus cos x, right? And right away, I can kind of see where we're going. I want to be able to cancel something out, so I'm left with a 1 plus cos x. So I see this and I think, difference of square. All right, you gotta know those previous math things, the factoring stuff, all right? So 1 minus cos squared x is kind of like saying 1 minus cos x and 1 plus cos x. Because if you were to FOIL this back out, you would get 1 minus cos squared x, right? Over 1 minus cos x. So this is really great because we can just cancel these two out. Let me just check off the steps that we've done. We're on canceling, and you're really just left with a 1 plus cos x. It's a really easy example because, yeah, left side equals right side, and you're done. Finally, just to close off, I really want to touch upon these steps again because I can promise you can watch a million just tutorial videos, but there will be nothing as good as practicing your trig identities to be able to get them, alright? Like, trust me, I learned this the hard way. Practice, practice, practice makes perfect. Do not get discouraged. It's really easy to get discouraged and just feel like giving up, but, you know, you gotta keep practicing, and your mind will just kind of, like, learn those tricks and just, like, follow those patterns, and you'll be able to solve any trig identity. So, thanks for watching.